am Shadashwara and welcome to Sada Learning Hub. Today's session we are going to learn about map interfaces, map interface in collection framework and their implementation classes. See here, map is an interface. It is available in Java collection java.util package. It is an interface. The map is some implementation classes is there. Those are the HashMap and linked HashMap and identity HashMap and weak HashMap and sorted map and some are there. Now I'm going to discuss about identity HashMap. See here, identity HashMap. It is an exactly same as HashMap except the following differences. In the case of HashMap, JVM will always use dot equals method to identify the duplicate keys. But in this case, the identity HashMap JVM will use double is equal to operator to identify the duplicate keys. In case of HashMap, the JVM will use to identify the duplicate keys dot equals method. In the identity hash map, JVM will use to identify the duplicate cards by using the double is equal to operator. Now I can show an example on this identity hash map. If you see this example, I'm creating in the hash map. I'm inserting the values into that hash map. I'm creating an integer objects, and after that I'm putting into the values into that hash map. I'm printing that values by using the system.out.println. I'm printing the object of that hash map. In the above program, I1 and I2 are the duplicate keys because 1 is equal to I1 is equal to I2. See, I1 is equal to I2. I1 and I2 are the both are duplicate object, same objects. But in the above program, I1 and I2 are the duplicate keys. You are putting I1 as I1 and I2 both are same. These are the duplicate keys because I1 dot equals of I2 returns true. In the above program, if you replace the hash map with the identity hash map, then I1 and I2 are not duplicate keys because I1 double is equal to I2 is false. Hence, in this case, the output is 10 is equal to Pawan and 10 is equal to Kalyan. Whenever we are printing the system.out.println, whenever we are printing that m value, it returns the 10 is equal to Pavan and 10 is equal to Kalyan. In the case of identity hash map, if you go with the hash map, it JVM will checks equals method dot equals method. In case of identity hash map, JVM will check double is equal to method. If you are checking the double equal to method I1 double is equal to I2, it returns false. If check the I1 is equal to equals of I2, it returns true. Next, I'm going to discuss about weak hash map. It is exactly same as hash map except the following differences. In case of normal hash map, an object is not eligible for the garbage even though it doesn't have any references. If it is associated with the hash map, that is hash map dominates the garbage collector. But in the case of weak hash map, if an object does not have any references, then it's always eligible for the garbage collection even though it is associated with the weak hash map, that is a garbage collector demonstrates weak hash map. Weak hash map is same as a hash map, but there is a one difference is there. The difference is, in the case of normal hash map, the object is not eligible for the garbage collection even though it doesn't have any references. If the associated with the hash map, that is hash map demonstrate the garbage collection. If the hash map is not eligible for the eligible for the garbage collection even though it doesn't have any references. If it is going to the weak hash map, the object doesn't have any references, it is eligible for the garbage collection. Even though if it is associated with the hash map, that is a garbage collector, dominates the weak hash map. I can show one example on this weak hash map. See here, I'm creating a one class. The class is called weak hash map. In this class, this is the main method. I am creating an object of weak hash map. I'm creating a temp class object. Here, this is a temp class object. In this temp class object, I'm overriding the toString method, and I'm overriding the finalize method. In this temp class, I'm creating an object of temp class. I'm putting that keys as a temp class. M dot T dot M dot put of T comma Sada learning hub, and I'm printing that one. It prints the object temp object. Yeah, we have internally it calls the toString method. I'm returning the temp is equal to Sada learning hub. After that, I'm nullifying the object T. Whenever we are nullifying the object T, I'm calling the system dot garbage collector. Automatically, it the weak hash map is eligible for the garbage collection. This is the example of weak hash map. Next, I'm going to discuss about sorted map. The sorted map is one of the child class of hash map. It is the child interface of map. If we want to represent a group of key value space according to the some sorting order of the keys, then we should go for the sorted map. Sorting is possible only based on the keys, but not based on the values. Sorted map interface defines the following six specific methods. Those are first key, head map, submap, and last map method, and tail method, and comparator method. These are the methods are available in the sorted map. Next, I'm going to discuss about tree map. The underlying data structure is a red block tree. Duplicate keys are not allowed, but values can be duplicated. Insertion is not preserved, and all entries will be inserted according to the some sorting order of the keys. If we are depending on the default natural sorting order, keys should be homogeneous and comparable, otherwise we will get the class cast exception. If you are defining our own sorting order by comparable, then keys can be homogeneous and non-comparable. There are no restrictions on values. They can be heterogeneous and non-comparable. For the empty tree map, as a first entry null key is allowed, but after inserting that entry, if we are not trying to insert any other entry, we will get the null pointer exception. For the non-empty tree map, if we are trying to insert any entry with a null key, we will get null pointer exceptions. There are no restrictions uh, for null values. Next, I'm going to discuss some of the next I'm going to discuss about constructors in the tree map. There are the four constructors are available in the tree map. One is the default constructor. It is used to create the uh, default natural sorting order. The next one is parameterized constructor. It takes the comparator object for customize the sorting order. The third one is tree map. It is a parameterized constructor. Sorted. It takes a sorted map. The fourth constructor is a parameterized constructor. It takes an map object. Now I can show one example on this tree map. If you see this example, I'm creating a one example. I'm creating a class called tree map demo. I'm creating an object of tree map. In this, I am putting the t dot value. I'm putting the values into the tree map. After that, I'm putting the values null value. I'm putting the duplicate. I'm putting the here all the keys are the integers, but I'm trying to put the key is the string key. It gives the class cast exception. Now I'm putting the null as a key. It gives the null pointer exception. Why? Because null value only if you are putting null as a key, it is only possible to the first entry of the tree map. It's not after it gives the whenever after we are putting the null as a key, it gives the null pointer exception. Now after that, I'm printing that a tree map. It prints like this. Next, finally, these are the implementation classes are available. Those are weak hash map, sorted map, and tree map and identity map. These are all the implementation classes of.
Thank you so much watching this video. Hope this lesson helpful to you. Keep watching our lessons. Keep writing to us. Do not forget subscribe our channel Learning Hub because we have many sessions that would help you to develop our skills, and I will be back soon. Till then you take care. Bye bye.